hearing. What happens at the hair cell? So this is the very schematic rendition of the hair cell. Okay. And this is kinocilium, and those are stereocilia. And they are connected by the tip links. So and here's the so this is tectorial membrane. I'm not drawing the tectorial membrane. These guys are embedded in it. And here's the basilar membrane. Essentially what happens is when the basilar membrane vibrates, the whole cell starts to move. And when it moves, the stereocilia bend towards kinocilium. As they bend, that opens potassium channels. And potassium flows into the cell. Try to answer yourself a question. Why potassium in this case flows into the cell and not out of the cell as it usually happens in other places? So what makes potassium freely flow? What makes potassium diffuse into the cell? So anyway, potassium diffuses into the cell. So when potassium diffuses into the cell, positively charged ions bring membrane potential up, make it more positive. We call it excitation, depolarization, right? So depolarized cell opens calcium channels. Calcium flows into the cell, okay, and causes the release of neurotransmitter. So here you have vesicles, same way you had in neurons, that release neurotransmitter that act on the afferent fiber and essentially produce the signal for the sound. So in the next video we're going to talk about the mechanisms that provide the same type of response in sensing the balance.